Hi, this is the presentation for Team 66's final project for CS6640, Introduction to Health Informatics. Our final project is a dashboard displaying healthcare quality metrics. So this presentation is going to cover three major components. The first is going to be an overview of the project, including background and motivation. We're going to discuss a bit about the data engineering required for this project. And finally, we're going to talk about the web application, including kind of the front end, the back end, and a demo of the web page itself. So hopping right into kind of the background and the solution that we created, CMS, the Center for Medicare and Medicaid Services, they use quality of care measures, QCMs, to determine reimbursement rates for healthcare providers and insurance companies. QCMs are aggregated population level metrics, and organizations typically need to be aware of how they're scoring in these measures, obviously for revenue purposes, but also to understand the quality of care that they're providing to their patients and their members. Um, this is somewhat challenging from a health data perspective because most health data out in the wild is going to be stored according to the HL7 FHIR specification. And that can make it very challenging and to aggregate these metrics or aggregate the data necessary to compute these metrics. So our solution is to kind of write an application which can go into these FHIR resources, extract the relevant data, push it all up into a database where it's stored, and then display it as a front-end dashboard to the user, with some visualizations and allowing the user to be able to easily adjust filters and subpopulations that they want to be looking at. So a quick overview of the design of our application. We obviously have the front end web page. On the left-hand side of the web page, there will be some filters the user can select to, select or filter down to specific demographic subpopulations. In the middle will be a display with like the data dashboard and, displayed as a bar chart. Obviously, all this is hooked up to a back-end application, which will query a Postgres database. So the quality of care measures we'll be using are breast cancer screenings, influenza immunization rates, Tdap and TD immunization rates, herpes zoster immunization rates, and pneumococcal immunization rates. All these measures can be found on the CMS Measures Inventory tool, which is kind of an online repository maintained by CMS and outlines exactly how these measures are defined. So going a little bit into the data engineering aspect of this project, we needed data, obviously, to feed our dashboards. So we generated patient histories for 7,500 patients using Cynthia for the state of California. The first major engineering task was to write ETL scripts that could interface with these FHIR resources and extract the relevant data so that they can be, uploaded into a Postgres database. Speaking of the Postgres database, the data model we used was the OMOP Common Data Model with some modifications made to help make the ETL process slightly simpler. The key challenge we kind of ran into was kind of computing the quality of care metrics in an efficient way and reporting them back to the user. So quality of care metrics usually require very complex multi-join aggregation queries inside of SQL. For example, the Tdap immunization, by definition, is the set of all patients 55 or 50 and older who had a Tdap vaccination 27 months prior to the end of the measure year. That itself is a mouthful, and you can already begin to imagine how complex the query would need to be inside of SQL in order to compute such a numerical quantity. And it would be highly inefficient for this database or the program to have to rerun this query every single time a user is requesting the data on demand. So our solution to this problem was to build these so-called OLAP cubes. OLAP cubes are an idea that we borrow from data warehouse engineering. And the idea is to kind of pre-compute aggregations at the most granular dimensions, the most granular level of aggregation, so that it becomes a lot easier to add things back up to get higher level aggregations or to slice down by applying specific filters along the dimension columns. In this screenshot here, you'll see a snippet of the OLAP cube for the influenza vaccination metric. You'll have the year, the gender, the race, the ethnicity, the city, the state, and the country. And at the intersection of these various different combinations of dimensions, you'll have kind of counts for the denominator and numerator, which makes it very easy for the API endpoint to then request a certain metric for a certain subpopulation. All it would have to do is apply the relevant filters in a where clause and then re-aggregate it all back up to get the final metric. I'll pass this over now to my team members to speak a little bit about the web application aspect of this project.
This is Vinay Dara, and I want to briefly talk about the backend part of the application. Also, I will be briefly going over the deployment strategy that we have followed to deploy the application on AWS. So offer in order to serve the front end, we have close to five endpoints, which are the metric endpoints, which will return the data in the form of JSON. And these API endpoints can quickly retrieve the QCM values for specific demographic subpopulations by leveraging the schema of the OLAP cubes. And each demographic subpopulation is defined by a set of where causes on the OLAP cubes, and the dimensions defining the subpopulation, they can be passed as query parameters in the HTTP request, which I'll be going through shortly and giving you an overview of how that looks like from the backend. Uh, if I have to go to the backend server as such, this backend server has been implemented using Fast API application. So we have used Fast API to design the backend in healthcare context, and it provides endpoints for user authentication as well as accessing the metrics data. As first thing the UI is going to do is it is going to hit this endpoint called /token, which is basically a post call, and it is going to send the username and password of the user. And then once the post call has been successfully authenticated by the backend server, the user is going to receive a JWT token, and it's basically the bearer token that will be used for the subsequent calls to retrieve the metrics. And in the subsequent calls, we have these endpoints for each of the metric that we have discussed previously, and in each of this call is basically a get call, where we are going to pass the bearer token that we retrieved from the token endpoint as an authorization header. And this takes care of the authorization piece, and we will get back the metric data and we will serve the front end in this format. Going quickly over to the deployment process, this is where I want to spend a bit more time. What we have is we have designed the deployment in such a way that we are using a Docker engine to spin up multiple containers within the EC2 instance in AWS. The Docker engine basically sets up three different containers. One is the front end container, which is hosting the AngularJS application. The other one is the back end container that is hosting the Fast API endpoints that we just discussed. And the third one is basically the data container that hosts the Postgres database, wherein we will be loading the Cynthia data as well as any vocabulary data that we will need for our application needs. As you can see, this entire Docker engine is being hosted in an EC2 instance that is running on AWS, and when the user hits the metrics UI application, the first thing that happens is the user will be redirected to authentication, and over there the security JWT security will authenticate the user, and the user will be returned with a token response, which the application uses to further retrieve the metrics data from the backend Fast API server. And within the Fast API server, if the using the token that is retrieved, the UI is going to make calls to different metric endpoints, and those metric endpoints are internally fetched from the Postgres tables, or rather the OLAP cubes that were previously created, and that data is sent back to the UI to be displayed for the user. Now quickly going over to AWS, we have an instance that is currently running, and this instance is hosting the Docker engine that we talked about. I wanted to quickly show you the security group for this because it's essential to understand that the security group will enable both the ports 8000 as well as 4200 over to the internet. The reason for this is port 8000 is currently hosting our backend application, which is the fast API application, as well as 4200 is hosting our front end, which is the Angular. So in order for the user from the internet to be able to access the UI, and for the UI to access the backend internally, we need to be able to opening up these ports so that the applications can talk to each other. Finally, I wanted to just go over the deployment and execution part for Docker. Once you have the GitHub repo cloned in your local, here are the instructions that you need to start the application locally. And once the application is started using the Docker compose command, you will be able to use these curl statements in order to talk to the application using the backend instead of using the UI. And this is one way to ensure that your backend application is working and you're able to retrieve the data from the backend.
Hi, I'm Rohit and I'll be talking about the front-end UI application. This is the login page for the UI application. We built the UI application with the Angular front-end framework. This login page allows you to log in, and the front-end application will use the entered credentials and send it off to the login endpoint and store the authentication token that gets returned. So let me go ahead and log in using the provided credentials. And once we log in, we get redirected to the metric display page. This is once the user is authenticated, they can query different metrics along with the different filters that we see on the left-hand side here. So I can demonstrate now by choosing the flu vaccine measure, for example, and pick Asian as the race. And we'll put the start year at 2017. And when I click the reload graph button, we can get data for every year starting from 2017 based on the quality clear metric flu vaccine measure. And this gives you the data and displays it in this nice graph here with a legend as well. We also have the ability to export this data as a CSV, and it downloads to the user's computer as a CSV file in case they want to do any further processing on it. The UI application also gives you the ability to reset the filters so that you can go in and choose a different metric and start again with your analysis. So once you click the reload graph button, you'll get the UI will pull the new data from the server through the metrics endpoint and display the results in the graph again. So to recap, our web application is built in Angular. We display the graph using the NGX charts open source package. The user is able to select any filters that they would like the metric name for the quality care metric, as well as the gender, race, ethnicity, and then pick a start year for the data. The UI then uses these selections to send a request off to the API endpoint, and the endpoint response is used to generate the graph. So this sort of presentation on the front-end application allows the user to see any trends in the quality care metric patterns for specific subpopulations that they choose using the filters that they can select. The quality care metric values can also be exported as a CSV using the export data as CSV button, and that facilitates business reporting use cases. So to go over the filters one more time, you have the different metrics that we have here, as discussed before, flu vaccine measure, breast cancer screening measure, the Tdap vaccine measure, herpes zoster vaccine measure, as well as the pneumococcal vaccine measure. Under gender, we have female and male to choose from. Under race, we have a bunch of different races here: American Indian or Alaska Native, Native Hawaiian or other Pacific Islander, other Asian, white, or Black or African American. Ethnicity, we have not Hispanic or Latino versus Hispanic or Latino, and then the start year, you can pick any start year within the selection. So this about wraps it up for the front end application, and I'll hand it off to my teammate to talk about the API endpoints and the AWS deployment process.